This is the physics experiment video analysis of Angry Birds. And the first thing that we did was we took a screencast of ourselves playing the game. And so we just kind of used the Google Chrome app and we took the screencast of ourselves on whatever. Okay, but we only used the first bounce to analyze. Okay, and then, so let's go back. I need to get to the video analysis. Okay, so we loaded it onto Logger Pro. We used this tool to get the different tools on this side. First thing that we did was we got our origin right here on. So we click set origin. We hit our video. Where is it? Where is it? Okay, so we kind of hit where the bird was pulled all the way back. And then right after we did that was we went movie options and we set it so our first video point was going to define our movie time as 0. And you could change this so that every time you add a new point, it will advance your movie 5 frames. But it just kept it as 1, just so that way, like, if you do a bad point, it won't be as like influential, but it does take a lot more time. And then to add a point, we use this tool right here, and we added all the different points. So let's play it with the points. See the yellow points on the screen. The bird's a little slow compared to my points. Okay, and then the next thing that you want to do that's kind of important to the video analysis, is actually really important, is to scale it. So you hit right here, set scale, and you click at the top of the Angry Bird and all the way down to the bottom. I had 0.9, which was not a very good scale, so we're going to just try 1 meter. Okay, and so let's make that a little smaller. And let's try closing that. So that's 4.9. That's really close because, okay, so our aim was actually 4.9 because that's half of 9.8, which is gravity. In our quadratic linear regression of our free fall of this Angry Bird out of our catapult. And we use this tool right here. So we sorry. So we want to click on this graph, make sure it knows which graph we're going to try to do, and then you click the whole region, you like quadratic, try fit 5.0, whatever. Okay, but we already had that one, so that's all good. And you can use this tool right here to check the slope. As you can see from this, the slope's always changing. If you're a calculus student, you can actually find the slope at each point, but since we're just physics students, we're just average slope. Okay, I'm gonna play. And so now we're on this graph right here, and this graph we can see that acceleration is always constant because it's 9.8. It's gravity. He's free falling in this video, so the only force acting on him is gravity. And then in this y velocity graph, you can see that the slope's also constant. And then you can see this one, slopes pretty much 0 in this whole thing. I'm pretty sure if I did it, it would be 0. But okay, and then, but if you do it just from scratch, if you didn't have your teacher do it for you, you would probably have to insert the graph, just insert graph, and you'll have to do that 3 times because Logger Pro only gives you 1 graph and 1 table, but you'll get all this whole table. Okay, and that's it.